now.
It's Python, Utah, North. Today's the 16th of August. And I got that right. Okay, today our topics are SQLAlchemy, and ALOK will be giving our first topic, which is basically an introduction to start off. And Brett will follow up with a more advanced or continuation of the same topic. So, ALOK, it's all yours.
Awesome. My name is Alok, and last time I decided that I'm going to give an introductory talk about SQLAlchemy. So in each week I'm a noob at this, and I've tried to put together an introduction, but it's not like it's really lightweight. I'm probably finished it in 15 minutes. That said, I'm using Jupyter Notebook as my IDE. Does everyone here have Anaconda installed or Miniconda installed, or even Pip? Yeah, Pip should do this trick too. If you guys have that, then installing Jupyter Notebook is pretty straightforward. You just type conda install Jupyter Notebook, that the highlighted section, and that should install Jupyter Notebook on your laptop. And once you have that in the terminal, all you have to type is Jupyter Notebook. So let me go back to that. Okay, so all I'm typing is Jupyter Notebook, and it works just fine. And what it does is it just opens up your browser and loads up any notebook you have. So once you have Jupyter, does everyone have Jupyter Notebook? Are we good to go on that?
What was the name of the package again? Sorry.
Jupyter, Jupyter, and space notebook.
Okay. With the space?
Yeah. Space. No.
Okay.
That's it. All right. So once we have that, I've put the repository, or rather the notebook that I was working with, on GitHub. So the link is I put it in the Etherpad, and you can just go to this repo over here and either download it as a zip folder, or if you know git clone, just git clone it. If anyone needs help, I can.
Should we also install like SQLAlchemy on my
Oh yes, I was going to bring it up, but. So the other commands you want to run is conda install SQLAlchemy and conda install PyMySQL. The reason I'm using PyMySQL is because I'm using a MySQL database, and what I found online was I need that like the module install to make this work. Anyone has another ways to make it work? Happy to change my code.
So, if you do the pip install, you do MySQL or
Oh, fine.
You're like,
Why is this not working? All right. Everyone ready to go? Okay, awesome. So once that is done, here are a few details regarding where the database is hosted. So there's a DigitalOcean droplet online right now, or VPS, with the IP address that I've listed here, 192.241.237.132. The database is, the DBMS, I should not put database, but the DBMS is MySQL. The user, I've created 17 user accounts with privileges to create, drop tables, add rows, do whatever you want with those tables. Only thing you cannot change is the actual users that can access the database. And the password is an Etherpad, which, okay, right here. So these are things you'll need once you go into the code. So that's Python star 0860 today's date. So pretty straightforward. Any questions up to this point?
So whatever it is, and then I can't really do it. Are you having that problem too?
Which, what are you just trying?
I don't,
Sorry, Wi-Fi.
I don't be able to access it through a browser.
Oh yeah, you cannot. The database cannot be accessed through a browser. If you put it in a like a URL, it's not going to take you anywhere because there is no Nginx or anything installed. It's just serving as the database, or rather has an open port for a database. So once you have all of that up and running, here's our first line of code, which is from SQL. A lot of people like to import it as from SQL import star. I prefer not to. I usually import each component as I want it. I don't know what's the standard in Python right now, whether they, I know recently there was quite a big ruckus on Hacker News about doing the whole import star. So,
It's frowned upon because it masks what you
really, okay.
You don't know where your packets are coming from. That's wise.
Okay. So, so from, and the other thing, I'm breaking a major rule is usually you do all your imports at the beginning of your script. I have decided not to do that just so that I can talk about what you're doing in each step. So the first step is from SQL, Alchemy import create engine. And what I'm doing is it's basically that there's this URL that you need to add, and that's pretty complicated. But you can, if you downloaded the notebook, it's just a matter of changing the username to whatever username you want from 1 to 17. And the password is the same for everyone, so you don't need to modify that. All you need to do is change Python 1 to Python 2, Python 3, or whatever you want. That's the IP address where the database is hosted. I haven't specified a port because it's on the standard port. The database in the DBMS is the engine is Python test, and use Unicode. I'm just setting up stuff. This I do not know what tool recycle is. I'm guessing that to talk about it later on if he knows what it means. So we start with that, and all right. So I hit run, and looks like my engine is set up. I'm connected to the database that's hosted on SQLAlchemy. The next step is defining a table, but to define, before I define a table, you need to import a few more bits of SQLAlchemy. So there are two imports that I'm carrying out over here. The first one is from SQLAlchemy.exe declarative, import a declarative base. This is what basically I think lets you set up a class which lets you define the table actually. And I'll show you how I've done it in the next step. The other thing I'm importing is basically the types. So there's column, integer, string. You could import other stuff like big int, binary, fit, etc., etc. if you wanted. But for the purpose of this demo, all I've done is imported these three: column, integer, and string. So this is where I use the declarative base. And please excuse my pronunciation. We do not consistently. So base is equal to declarative base, creating a declarative class. And this is where I actually define the table. So class user, that's the name I've given as users, and it uses base as the argument that I'm passing to it. Table name in the database will be users again, and these are the columns in it. So there's username, first name, middle name, last name, and password. I picked up these columns straight away from Brett's tutorial. Yeah, go.
Control plus like a couple of times
Yeah.
to increase your font size.
Does it look?
Yeah. One more time. There you go.
Okay. Alright, so that's where the problem. So I picked up these column names straight away from the tutorial that it's going to go into in some time. And basically, through this, to the base that I created, I'm finding the engine that we had connected to before. And then what I tell it is create all the tables that I've defined. And in this case, there's only one table that's being created, that is the users table. Next part comes is to actually put stuff into the table. And for that, I found there's something called the session object that you can create, and the library or the module that uses the session maker. So from SQLAlchemy.org, this is where object relation mapper comes into the picture. Import session maker, and I've imported JSON, which I should talk about later. Right now we don't need it. But basically what I'm doing in these two lines of code is, again, creating a session and binding that session to the engine that we had created earlier, then using the same session to add new records to the database, specifically to the user table. So the user table had a few columns that we had defined. Username was the primary key, so you can't leave it blank. So I've defined these two records. First name, ALOK, web, null, what, and password as Python and Python 20. These ones like password and username were defined as not nullable, which means you cannot leave those blank. For everything else, you can leave blank as you wish. On to the next step. And then finally, SES command. This is where actually the records are written into the database, into the table rather. And until then, I'm guessing it's not really inserted into the table. So just to know if, hold on, what I'm not doing is running on my code. Okay. Yeah, added, and now SES command. Oh, error. Duplicate. Oh, that's because I've run it already. What? I'm guessing I've run it or someone else has run it, but either way, those records are already in. You can change those records to whatever you want, and oh boy, that's not fun.
It's the time for music.
Is I guess Brett, do you know anything about what I'm facing?
I think you could maybe just move it.
Change all the IDs of the users. It'll work.
I think mostly you're running into duplicate primary key problems.
Yeah,
Okay.
just go change the usernames, like have you paid each of those usernames.
Nope. No. Oh no, I did work. So now it's giving me all the names. Let's see with the username. Okay, so now there are new records inserted into it. Then Brett's going to talk about creating elaborate tables, and I just chose one small section so that we can just continue with it. This is where I read the test_data.json, which Brett's uploaded to his repository. And I'm specifically accessing only the users' records from his JSON file. And let's try into that. These are all the records that are in there. There are 3 records, 3 usernames that he has created. And those are the ones we're going to insert into the table. Has anyone run this yet? No? Okay. So, okay. So, yeah, pretty cool usernames. So, to go over the code, it's just using a for loop, using SES add all, that's the function. And I'm passing each record to it, telling it that it needs to go into this users table. Each column gets these following records from, or other key values from the dictionary. So it's done. Looks like it did work. Now, okay. So now they are all in the big table. So if I print or rather get all the records and print them, we get all the creative uses that we have put in there. That's pretty much all I have for my introduction. Any questions, anything that I can try to answer?
You know, on that session, if it's something that you have to explicitly close.
Oh, I think there was something about it that we need to close at the end of doing everything. We need to close the command. Until then, it closes everything.
Even after you commit.
Yeah. Is it not that way?
I'm not sure. Who's can answer that?
Once you commit it, it is committed.
Committed. What I would use, but
Saved to database.
But is it you need to like close the session after you're done?
So the session for SQLAlchemy is going to keep a bunch of objects cached.
Right.
So that's what you would want to close it for, is just in memory. But everything on the database
Is
is
already
fine.
there. Yeah.
Already committed.
Committed.
Right, so you don't need to close your session every time you commit.
Right.
But
But,
what you-
at the end of after
Right.
doing whatever you want to do, you
Yep.
close the session.
It's like an open file handler. You want to close it at the end.
After you.
Other questions?
Okay, I apologize. I kind of fell behind a little bit. Where I have to throw open, but where how do we access that file that you have?
It's on GitHub. So if you
okay.
go to github.com, the link is on Etherpad. Are you?
Yeah, I have the okay. Okay, yeah, I see it now.
And if you open it, go on your GitHub and you click on raw, you need it for raw, I type on notebook files. Then if you go to Jupyter and just say upload, you can put that URL in the file path. Yeah, just Jupyter.
Just type icon. There you go.
It's Jupyter.
Yeah, nice.
Thank you. Now we'll continue with Brett.
All right, hello, I'm Brett Ward. I'm going to be doing some sprints for us today using our SQLAlchemy. ALOK did a good job of giving us an introduction into what we'll be doing tonight. So, there is, all right, before we get started too much, who here has a GitHub account and wants to be a team leader?
I can do that.
So you two, you can do one. Probably would want, is 3 groups going to be enough, or we want 4?
Why do we need a GitHub account?
Just so that we can do our combining of it.
Oh, cool.
We're going to be doing I'll get into that a little bit
Fine.
later.
I will
show how it's
confess
done.
to having a
but,
GitHub account.
but yeah, he's got one the other day. So you two all sign mine, you'll be the 3rd. You want one more? You need one more team leader. Dave can do it. Okay. All right. Okay. So basically, my premise is, so have you ever used a budgeting tool like Mint? I think Intuit has Mint, and Dave Ramsey has like $3 budget tool types of things. So everybody's probably used something similar to that. My problem with those tools was it allowed you to go to your bank maybe and download the transactions, or you type a transaction, and you would assign that transaction a budget. Well, what if I went to Macy's or a grocery store and I bought groceries, and I bought some fuel additive, and I bought a couple other things that I want to put different budgets, but on the same transaction. So we're going to create a little database here, and that It's going to let us itemize, basically budget with itemizations, right? Let me show you our model. I can figure out how to use Linux again. All right. But not so. All right. So here's a little table of what we're going to, the tables we're going to create. And you guys are somewhat familiar with the users table already. ALOK showed that in his presentation. So basically how it works is we have this base element table called itemizations. That's going to contain our budget. It's going to contain a foreign key to our budget. It's going to contain a foreign key to our transactions. And it's going to have a name and an amount. All right, that's going to keep track of how much money was spent for this budget for that transaction. All right, we then have a budget which has the budget name and it's got a group ID foreign key. So, and then it also has an amount in sense. The amount for the budget is the amount that you say you want to budget for. Right? So your items contains the amount in transactions or amount actually spent. The budget groups is just to categorize things a little bit nicer, so you can have like a food thing, a food budget that has a budget of groceries and fast food. Right? Does that make sense? Hopefully it's pretty easy to understand. Transactions will contain a foreign key to the users table to tell us which user was purchased that or used that transaction. And we'll have a name for that transaction and a date that it was transacted. All right, and then the user table, you saw it has username, first name. A lot of this stuff I added to the users one just to show you some examples of the tables. We're going to be creating tonight these 4 tables: the transactions, the itemizations, the budgets, and the budget groups. The users I have created for us so that we can have an example. All right, I will show you now the budget. So I broke out the code. It's kind of hard to see there. Oh, I guess we should probably, if everyone who has GitHub, go ahead and fork and clone that repository that I showed on there. It's the, I got 2 more screens open here. This one. Yeah, this one. This one here. If you go here and you fork that, create your own version of it if you're a team leader. And then we'll get into how to merge that in a minute. But all of the,
No branches.
there's no branch. So we're just going to clone this, put a .git at the end of it. We're just going to clone mine here. You're going to go to the website to fork it. You'll need to go to that website. And that's going to have the code in it if you want to look at the code. So I've broken it up into a models. Okay, so models is going to be our class is going to contain our table names. Our classes are going to contain tables, right? And this isn't necessarily the only way to do it. This is just the way I've approached it for the example tonight. As ALOK showed, to do our imports here. These are just some system stuff we're going to use. And these are the things we're going to use in this particular models library. Is you use a declarative base. We're going to use our relationships. We're going to have back references, which is part of our relationship. We're going to have our column, a foreign key, and sequence, and then from the types, we're going to use date, times, integers, and strings. We might want to use more types later. I don't know. It depends on how advanced we want to get. In coding, I just use it for the hash label. So here we're declaring our base, like ALOK showed, right? So we're not going to have to create a base or anything like that every time we create a new class. All we're going to do here is, so here we've got this user table set up for this class here for the users, right? When we create our tables, you guys will have this code from that Git repository, and you'll just add your new class to the bottom of the file, right? When you add it, when we add a new class, we're going to inherit from base. Base is our declarative base that SQLAlchemy provides, which gives us the whole background how it works with the database. It also allows us to do the keyword assigning of the fields like you saw a lot. So when we create an instance of this class, we can say username equals the username, and it will assign it. All right, so here we've defined the table name, the users. We have our columns. For an ID, it's going to be our primary key, just a sequence. The sequence here, you don't need, and we're just going to be using SQLite for tonight, but this would be handy if you want to, if you're creating your tables in like Postgres or MySQL, it actually would create a sequence object in the database with that name. So that's good to be explicit there instead of having it do what you don't necessarily can't keep track of your sequences. Username, it's going to be a string of 64. So in the Postgres database, you would see something like varchar 64, right? So we specified 64 here. You don't have to. SQLite doesn't require us to specify it. If you're ever going to build your tables, it's better to specify it in case your database requires a number. We are going to say that the username is unique, and we are going to say it's nullable. It's not nullable, sorry. It's false. So you can't have a null username. Then we have first name, string, middle name, string, last name, string, created, which is a date, timestamp, assault, and the password. Right? I don't know. Assault is just some random information that you concat to your password so that you can have it more randomized. Because in the database, we don't want to store the password, right? We want to store the hash of the password, maybe. So we have a hash of the password, but to make it more unique in the database, you actually hash that against assault. So your database means nothing. If you can reverse engineer that hash, you still don't get the password. Yeah.
If you hash without assault, then somebody can generate a table of all possible passwords and what they hash to. And then if they crack into your database, they get the hash and they just look it up in the table. If you put a salt on, and it's a different salt for every account, they can't pre-compute the lookup tables and have any speed benefit, because it would be a different set of tables for every salt. That's what the benefit is.
I added it here not because this is the best way to do this. It's just a field that I could add and show you how to use some stuff. So and then we have our init here. So you can redefine an init. You don't have to, because your base that we inherited is going to do this for us, and that's going to assign the keywords that we thought. So here when we call our init, we're going to pass in our keyword arguments variable. I don't know how many of you know this is a pretty advanced thing. I don't necessarily want to get into it, but it just works. So just do it if you want to do your own. If you want to do your own init in your class here, do this so that it will pass through all those keyword arguments of username equals, and it'll go through the SQLAlchemy object that it has created and assign those properly. And then after you call that super init and pass those through it, then you can do whatever you need to do for your class. Right? So that's some advanced Python object-oriented stuff, but this works. Just do this if you're going to want to do anything here. So the reason why we're doing an init here is when I create a user, I automatically stamp it. This is when it's created, right? So I'm using the date time library, and I'm saying UTC now, which gives me the current timestamp in UTC, and it's going to set the created time to that. Right? The salt, we're going to call this function, this method we created. We'll get to that a little bit later. Password, we're going to call this method. We're going to create a new instance of this method. All right, this relationship I've commented out right now because the other tables don't exist, but this is what a relationship would look like once you try to relate these together. So it's just this relationship method. You tell it what object that you have that you want to relate to, and you can give it some word information, and then you create a back reference if you want, so that so that if I have an instance of the transaction object, which is what this is, I can actually say .user and get this information from that one key.
What is the order by?
Order by descending transaction date. So this would be a column inside the table of transaction, and it's going to. So this is going to be a one-to-many relationship. So there's going to be one user, and it's going to have lots of transactions. So when I say this user dot transaction, it's going to give me in order by transaction date, just descending order by transaction date, a list of all of those, right? So it's going to handle all that relationship, all that foreign key lookup for us. And then the back reference, if I'm in an instance of transaction, I have an object transaction, and I say .user, it's going to give me an object of user. String, this render stir is just going to pretty print it for us. If you ever call a print method, if you're ever going to look at this object, this class of a string, it's going to print this. And then the repr one is basically the same thing, except for when you're in like a Python console, and it's just calling the string. So it's going so clear. I'll show you the Python console in a minute here. Then our method here for salt, just made it static, and it's just throwing out the timestamp and guiding text or hashing it up. Okay.
Don't actually create a salt pattern.
Yeah, don't. That's why I said don't use this as a salt method. You want true randomness. You don't want sometimes that, because smart people like can figure things out and do certain time ranges and create their tables anyway because they're smart and they can do that. So true randomness, however you can find that, I don't know how, you can find it, that's what you want. And then the get password is just going to take the salt and the password and hash them together and return that, and that's going to be what, and that's what we throw into our password. So the database is concerned, all we get is that hash of the password and the salt together. So I just want to show you that you can create methods inside these classes. They are full Python objects. You can do whatever you want to them, aside with all that SQLAlchemy stuff together. Right. The next piece that's important to understand, but not necessarily, you won't have to worry about too much, is there's this file that's called SQLite engine.py, and it is going to be our engine. This is where we're going to create now this is where we import our base, and right now I'm importing the user. That's just so we can import data into it. So the idea with the SQLite engine is it's going to be what's going to create our session. Right, so that's what, when ALOK showed us that session, this library is going to do that for us. So all we have to do for our exercise tonight is import session, or import session user, really. I'll put it through this. So this we can actually create the engine. It's just a SQLite engine in the database name of database that we do. Right, so easy change. The idea of this is a development thing. You're never going to use this in production or anything like that. But if you wanted to use like Postgres or MySQL, you'd actually create a new engine that could connect to that, get the password information you need from somewhere secure, and maybe even do migrations for you if you want to migrate it. So what this is actually going to do, if you run this, it's going to call the main. It's going to delete the database that's out there, and it's going to create the tables again, and it's going to insert data into it again. So if you run this, we're going to get a database populated with data. All right. So for our stuff tonight, we won't have to worry about entering data in for our things. And I've commented out pieces of it because we don't have all the data built yet. This part here is a very Pythonic way of using SQL. Context manager, if you've ever opened a file in Python using the with, say with open and then the file as your handler colon, and then when that with ends, closes out, that's the context manager. That's what a context manager is. So here what we're doing is we're creating a session inside of a context manager. So when we use this, we're going to say with session scope as session colon, and then anything inside there. So this is what's going to happen behind the scenes. So what we're doing is we're going to create a session just like ALOK did. Then we're going to yield that. This is a generator. It's going to yield that. So basically we can do whatever we need to do. And when it ends, it's going to come back and it's going to commit it and it's going to close. If there's an error, it's going to capture that error, roll back the database, and fill it up. Right? So that's just a very Pythonic way of using the session, using the session scope. You don't have to do that, but that would be right, so those are the main things you need to know about it. This. If I were to run here, what engine is going to run that compare table, right? So you can see our table in there. We've got our users table in there. We do a select statement. We're going to see that data in there, right? So those are the users that we had there. You see that we have, this would be the password field. It's just that hash, so we can't get into the really bit and figure out what the password is. And here's our solve. So you see that that just looks good. So, quick little example. If I were to import from SQL engine import session, and I want to from models import the user class, right? So then I just need to get my session. So session equals session. Then I want to say, hey, I just want to get my users. Okay, I want to query my users. So I say users equals session dot query user. And this is going to generate all the SQL code for the database and get me a list of those users. So if I print users, it's just going to be a list, right? I can't see that. But if I did like for user in users, I need to print some of the record here. Just to call it, I need to print. We should see kind of all over here. And that's that pretty print string function that I did. So you see the name, first name of the date, that's what I put in there. So that's how you could use the objects, right? Pretty easy to do a query, right? You don't have to worry about select anything like that. It's all in the ORM. Very similar to Django if you go use that. All right, so we have these stories. Yeah, I guess it's any questions before we move on.
On that query, when you wrote the user object, let's say that we had that relationship to transaction setup. Is there a way that you explicitly tell us whether or not to load child objects, or is that?
So SQLAlchemy is lazy by nature. It's not when I so here I actually have a working thing of it. So the question was, when we queried the user, if there's a relationship to the user object, would it calculate all that list of information? And the answer is, I think it does. It actually will query that. And well, okay. First of all, it's lazy. SQLAlchemy is lazy, so it's not going to run this query until you use that object, right? But once that object is used, it will query all of those. So if you have objects with huge amounts of relationships, there is a setting you can set. And I don't remember exactly. It's something. It's lazy equals something on one of the declarations. If you do that, it won't actually go out and find those until you want them. But by default, I think it does calculate that list once it's used. So the next step would be to break into groups and do these stories. I have 8 stories. Each one is create this table, create that table, create that table. So first goal would be create all the tables that we need. Do we want to do that? Do we all want to stay that late? It's already 7:45. If people want to stick around and do that, I mean, I don't think it should take very long. But what's the consensus? Do our team leaders, do they want to? There's 8 stories total, but the first 4 are just creating the database tables, the classes of objects. And then the next ones are like create a report. I can show you an example of that report. The one I already done. That's just going to give us all the information from the database. You want to do it that way? Okay.
It's still new with getting the word with the checked out, so.
So the let me show you then complete code to the model so you understand all of those classes real quick. So then we have our user class we talked about. We have our budget group class. And it's just got those names, it's got that relationship that we talked about. I'm going to show you that chart. There's your budget, your transactions, your items. Okay, so they're all there, they all exist. And then, so the story, let's do the story of the budget report. So we want to create an application that uses our models to create a budget report. And the report should list the budgets, the budget amount, and the total spent for that project. Right? So maybe we want to list the budgets, right? So we go to, let's just go play around a little bit here. What were I on? Budget, food, the condition and the items, right? Those are our objects, our tables, right? We have all those tables. So our story was to list the budgets, the amount, and the total spent for the budget. So we want to list our budgets. What would we do? We would say, do we want to do what budgets? Do you want to do your query in a for loop, or do you want to create into a variable? Does it matter?
Let's go to a certain method. Let's go to for loop.
Okay. Or it really depends if you're going to use that information more than once, right? If you're going to iterate through it once, then just do it in the budget there. So for budget, and before we do that, we need to prepare a session. Okay. Alright, so for
There's a reason when you created that session, you didn't have to find it for a specific engine.
It's already bound to an engine in that SQLite engine that I showed you. So when I import session here, it's already bound to that engine.
Okay.
The idea is if I have, this is for development, if I have a stage or a production engine, I'd actually have another engine out there. And then I would use that one. And it knows how to communicate to that database. And this one knows how to communicate with the test one. Whereas in this test one, every time we run it, we wipe it out and reload it with data. In production, you probably want to do some migration work in that. Right? But I mean, it's really just a quick easy way for us to do it.
Obviously, use the session maker.
Right. So I could do a session maker here and show you how to do that. The problem is I'm within a width block and it's harder to, I can't get any of my IntelliCode sense that way. In the console, I won't do that. I'll show you that in the actual script when we do it. So for budget in session dot query, right? What are we querying? Budget. And we want to list those. So we want to query the budget dot name that we want to see. That's going to list all our names, right? So we got our names. So that's how we query those budgets. Yeah. They were probably in the order in the database by the ID. They're in order by ID, I'm guessing. Yeah. So, I mean, that's how you query the budget. Obviously, to build a report, we're going to need more information on that. So let's switch over to the script. So in this application, we imported the session scope. We're not importing the session. So here we're going to see that. So we're going to say with session scope as a session. We're going to query our budget, right? That's what we just did. And I'm also creating some variables so that we have some table headers. Right? And then we're going to go through those budgets. We're going to go through those budgets. So we're going to say for budget in the budgets that we queried, we are going to concatenate the name of that to our header so that we have the name of those budgets in the header. And then we have the amounts, and we're going to concatenate the values of those amounts into the next line. And then we have to count all the items, right, that belong to that budget, because all the items, we have to do all the items, lots of transactions for those. So we have to read through those here. So now we're going to port through the item inside the budget.item. So this is that foreign key relationship right there, right? So the budgets have a relationship of items. But this is all the items belong to that relationship. We're going through and we're adding up those. And then we're adding that to our thing and we're making it pretty by formatting it and dividing it 100 so that it's in dollars instead of cents. We can talk about why you do that another day. You guys probably know that. Yeah. And if you ran this, you're just going to see a tab below the big thing so that you can easily open it in Excel. I'm just printing them so you can just override the standard out table report. Yeah, so here we've looked through. You see this little code that we have here, this little session scope. We've created a database, we pulled all the budgets from it. We've got all the budget amounts that we budgeted for, and we got total spent and all those. And all it took was this little code, no SQL, and ourselves, or anything like that. Yeah. So, and maybe we can try to do my thing another day, but we actually work on it. But
What I find is for that post that does the download is written from the GitHub.
I will commit all of my working code that has the stories completed in it in another branch to that repository code. So you can see complete code, or you can go through it and just do the stories yourself if you want to. The really cool thing that, one of the things I really wanted you guys to learn from that was you can take these objects and do things to them, right? So like we hashed those passwords, right? Well, we're storing the amount in cents, right? So because floating point arithmetic is not very good on a computer. We really use precision. It's estimating a lot of times. So if you store them as integers in cents, integer mathematics is really good on the processors and kind of that. So here we define properties and you can print that in dollars and things like that. Or you can set the amount as a dollar and it will multiply by 100 and set it in the database as cents. I just wanted you guys to kind of see the property correlates and getting the data into the table.
I also posted a link to discussion of lazy.
All that.
What's that thing?
That was a big problem, and they addressed it in an update. And that lazy thing, I think, is what makes it so complicated to build.
Questions?
Thank you, sir. We have one more thing.
Yes.